Algebra 2 Final Review Part 4. This question is broken down into 3 parts. One in which you have to write an equation, one in which you have to graph an equation that was just written, and then the third part is using the information to answer a question and to solve an equation. Part 1. Darlene is evaluating her retirement savings. She currently has $218,000 in her account, which earns an interest rate of 8% compounded annually. This formula uses this situation compounded annually would use the formula A is equal to P, which is your principal amount, times 1 plus R, which is your interest rate, raised to the T power, which is the amount of years. She wants to determine how much she will have in her account in the future, even if she makes no additional contributions to the account. Write a function A of T to represent the amount of money that will be in her account after T years. So we're going to use that formula. A of T is going to be your output, and this is going to be determined by the principal amount, which was the initial amount she started with. She invested $218,000 into the retirement savings. That's the principal amount. Open up parentheses and put 1 plus, and now we need to figure out what R is. Well, it was an 8% rate, and we have to make that a decimal. R should be a decimal. To make it a decimal, we move the decimal point 2 places to the left. The R value would be 0.08. 0.8 would be 80%, so we would like it to be 0.08, which is 8%. 1 plus R, which is 0.08, and this is raised to the T power. The equation's almost finished. The one thing that we would do is condense up what's in parentheses and make this 1.08 raised to the T power. Now we want to graph this, so we have our grid set up. Before graphing it, we need to find some values. They would like us to graph A of T, the amount of money in the savings account, the retirement account, when T is greater than or equal to 0 and less than or equal to 20. So we're looking from 0 to 20 years. We're looking at our input, which is T, the amount of years, and our output A of T, which is the amount in the account after that many years. We're looking from 0 to 20. The best thing to do would be to count every 5 years. So we want to find out what is A of T when T is 0, when it is 5, when it is 10, when it is 15, and when it is 20 years later. We're going to use our graphing calculator to help us with this. We're going to go to y equals and plug in the equation, which again in this case was 218,000. Parentheses 1.08 raised to the x power. We'll use x for the input since there's no t button. We're going to do second graph to access the table and scroll down to see when time is 0. When t is 0, the output value is the amount of money invested, 218,000. We're going to scroll down. You see 1 year later. We're going to go all the way down to 5 years later. 5 years later, $314. Scroll down to 10 years later, $470,646. Scroll down to 15 years later, $691,533. And 20 years later, where they want us to cap off, that output value would be $1,016,088. We're setting up our t values from 0 to 20, and I allowed each box to represent 1 year. However, we needed to come up with an appropriate interval for the output values, and they're in the 100,000 range, so I'm going to let each box represent 100,000. This would be 100,000, 200,000, 300,000, 400,000, 500,000. I put 500K to abbreviate it. 600,000, 700,000, 800,000, 900,000, 1,000,000, or 1,000K, which is a million. All right, here's the million mark. And then I go up to 1,100K, 1,200K, 1,300K, 1,400K, 1,500K would be good enough there. We're going to plot the values that we just found. 0, 218,000. T is 0. we're going to go up to 200,000 and go a little bit above it and put our point there. 5 years later, we're at 320,000. We're going to have to estimate this. So we're going to go to 5 years. We're going to go up to 300K and a little above for 320,000. 10 years later, you're at 470,000. So we're going to go to 10 years. We're going to go up to 400K. And 470K would be closer to 500K. So we're going to go a little bit beneath the 500,000 mark, 500K. 15 years later, we're at 691,000, which is going to be a little beneath 700K. 15 years later, a little beneath 700K. And then 20 years later, you're 16,000 above 1 million. So it's going to be a little above the 1 million mark, which again is the same. 1 million would be the same as 1,000K. Or 1,000,000. 6 zeros is a million. And then we're not going to use a ruler to connect this because this is not a straight function. This is a curved function. And it's going to be a continuous upward facing exponential curve. That's how you would graph this function.